The James Webb Space Telescope is flexing its muscles once more. In addition to focusing on the universe's darkest mysteries, the most potent space telescope ever constructed is giving us breathtaking views that reveal the universe's architecture in previously unheard-of detail. The incredibly fine Webb photographs make the formations seem as close as your fingertips, even though they are occasionally several million light-years away from Earth. The first amazing image from our film, however, demonstrates that the technically assisted vision of the stars may also reveal some odd, if not outright bizarre, object. Since Webb has captured a glowing penguin and its egg in the expanse of space, we think that's quite good. Astronomers will clarify, however, that the picture depicts the ARP-142 pair of galaxies, which are located roughly 326 million light-years away and have been engaged in a close dance in space for a considerable amount of time. The two galaxies, which are part of the Aquila constellation, have been combining for 2575 million years. In a few billion years, the Andromeda Galaxy and our Milky Way are predicted to meet this fate. But in the case of ARP-142, we are dealing with an irregular galaxy and an elliptical galaxy rather than two spiral galaxies. The latter are renowned for lacking both symmetry and distinct structures, as the name implies. However, it is evident that irregular galaxy NGC 2936 has generated remarkable tidal arms as a result of its contact with its partner, NGC 2937. Webb's false color image in the near to mid-infrared gives the impression that NGC 2936 is flinging cosmic confetti, and for good cause. In reality, a high rate of star creation that is noticeably higher than the Milky Way's is present with the massive gas and dust clouds. In contrast to the 6 to 7 new stars that emerge annually in our own galaxy, NGC 2936 experiences up to 200 new stellar births annually. However, a little patience is still needed before the irregular penguin can accept its elliptical egg, which is primarily composed of older stars and has a lot less gas and dust. The present distance between the galactic pair is around 100,000 light-years, or the Milky Way's diameter. Before the two structures combine to form a new galaxy world, several hundred million years will pass. An integrated perspective of the creation pillars. By itself, the images of the magnificent pillars of creation are not new. In fact, the massive star forge was photographed by the Hubble telescope in 1995. Before Hubble returned to the object in the Eagle Nebula, some 7,000 light-years away, in 2015, other telescopes took more accurate pictures of it in 2007 and 2011. None of these pictures, however, compare to the ones Webb showed the stunned public in 2022. Even those structures in all their facets that were totally unseen in the photos of its predecessors are revealed by our new eye in space. The curved lava-like lines are simply the rays that the newborn stars in their cocoons constantly fling at the surrounding cloud material, while the newly developing protostars appear as reddish balls at the ends of the pillars. But as NASA revealed a few weeks ago, the new composite perspective of the pillars of creation reveals that we should not yet disregard the Hubble images. The Hubble photos display the hot gas components of the stellar cradle that glow in visible light, while Webb's infrared data displays the cool gases and nascent stars. The king of our planetary system, Webb is most famous for locating the oldest and most distant structures in the observable cosmos, but we should not forget that it occasionally looks at our nearby planets. The intriguing pictures of Jupiter, which present the king of our planetary system in a way never seen before, demonstrate just how new the perception of the familiar may be. That is taken pretty literally. The subtleties that Webb made visible would be invisible to the human eye. Webb's NIRCom used 3 filters to capture the light reflected by the gas giant in order to eliminate our natural blinders. This allows for the evaluation and display of infrared radiation from several wavelength ranges independently. However, the matching wavelength ranges were subsequently converted into visible hues because infrared energy is invisible. In fact, the astounding amount of detail left even the most seasoned professionals in awe. In addition to well-known features like the Great Red Spot or the Aurora Borealis, the Webb photos display the small moons Amalthea and Adrastea, as well as the delicate ring system, which is typically only visible in passing. Our backyard's first up-close view of the super Jupiter, With a minimum diameter of 140,000 kilometers, Jupiter is the greatest planet. Theoretically, our Earth could fit into it more than 1,300 times. However, we must acknowledge that there are objects out there that literally make even Jupiter appear old. If we allow our eyes to go 12 light-years further and examine the star system Epsilon Indi. In specifics, the mass of the exoplanet Epsilon Indi Abe is 6 times that of the largest planet in the solar system. Not only that, but the alien world also represents the oldest and coldest exoplanet discovered thus far through direct imaging. In theory, the majority of direct photos of exoplanets to date depict young, hot gas giants, which appear as relatively brilliant points of light in the infrared spectrum. In addition, all 25 of the exoplanets that have been directly observed so far are younger than 500 million years, and most of them are even younger than 100 million years. The chilly superjupiter Epsilon Indi Ab, which has actually been around for roughly 3.5 billion years, is a very different story. It is currently being used by researchers to test planetary evolution theories and answer unanswered concerns regarding the late stages of exoplanets. What's left over after a star dies, supernovae are without a doubt one of the universe's most potent displays. A big star collapses and says goodbye to the cosmic stage in a catastrophic explosion as soon as it approaches the end of its life cycle. The Webb image, taken a few months ago in the constellation Cassiopeia, now provides a detailed view of what a field of debris looks like following such a star death. More specifically, we are examining a high-resolution near-infrared image of Cassiopeia Ei, a supernova remnant that is evidence of an event that took place there some 340 years ago. One of the most researched supernova remnants is the structure of luminous gases and a center neutron star, since the stellar debris is so close to Earth. Although Hubble and the Chandra X-ray Observatory have previously analyzed Cassiopeia Aa, Webb's NIRCom revealed the filaments that the star left behind during its 1,680 violent end. Bright orange and soft pink are the colors of the structure's inner shell, which is made up of several elements such as argon, oxygen, neon, and sulfur. The moment where the supernova shockwave enters the surrounding circumstellar material is indicated by a sort of white glow that resembles smoke and is seen outside the inner shell once more. In this sense, scientists believe that the intense glow is caused by synchrotron radiation, which is light from charged particles rapidly swirling around magnetic field lines. It appears as though a potential supernova is dormant near the image's lower right corner. It's called Baby Cassiopeia, AE, and it's most likely a luminous dust field that the shockwave only caught and heated long after the star explosion. The structure is around 170 light-years away from the supernova remnant, despite the photograph giving the impression that it is very near to Cassiopeia A. Never before has the Serpent's Nebula been so intricate. An interesting insight is often included with a brilliant family portrait. In addition to revealing brand new information on the 1,300 light-year distant Serpent's Nebula, the James Webb Telescope also gave astronomers a vital hint about a unique feature of nascent stars. In summary, the researchers discovered a collection of gas jets known as protostellar outflow jets, which originate from young stars and interact with the surrounding gas and dust in this early stellar nursery. These outflows typically point in diverse directions, but in this instance, they all point from the upper left to the lower right. The idea that nascent stars have a tendency to revolve in the same direction when their gaseous birthplaces collapse is subsequently supported by this finding. The explanation for why scientists have just recently noticed this specific element of the Serpent's Nebula is straightforward. In earlier pictures, the structures that resembled flames were either blurry or not visible at all. Fortunately, the optical obstacles of the past are no longer an issue because Webb's high-resolution NIRCom can pierce the cosmic dust and gas clouds. You can now also put an end to the instances in which you haven't clicked subscribe. To ensure that you never miss another one of our videos, hit the like and subscribe buttons right away. See you soon!